Hey everyone. Hey there, Kartikey. First of all, so sorry for being a little bit late. Not a little bit, but it's fine. We had some technical difficulties, but finally we are live. And I would like to thank Kartikey for joining us in our last session of Open Spectrum. So today we are going to talk about how you can empower ML with open source. Now, what do I mean by that? Karthikeya has some great slides and a great presentation for that. So let's just wait for a couple of minutes and see if everything is fine.
Sure,
Till
and
then,
really sorry, folks, for those who are seeing me like kind of late. It's kind of a technical difficulties from my side, so really sorry, folks, for that. Yeah,
that's totally fine. That's totally fine. How you have been, Karthikeya?
I'm doing great. Somewhat work going on a work side, also simultaneously, and doing side by side on a community stuff. So, kind of really kind of hectic kind of thing is going on. Yeah.
I know, but this actually inspire a lot of people, including me. So yeah, cool. So let's not waste your time or
Sure.
my time, and let's just start with the session. You can go ahead, and I'll share your screen. I'll be going off stage to take some notes, and I'll see you on the other side. Bye bye.
Sure. Thanks, Adarsh. Thanks, Adarsh. And yeah, I guess we can simultaneously work on it. I hope so. My voice is also audible to you all. Cool. So this is a kind of a roadmap for the, you can say, if you want to get into open source in machine learning in general around it. So talking about me, I am right now associate open source license at a company called Cote. And apart from that, I am a TFEG organizer. I'm also a working group and SIG member of TensorflowJS. I also a contributor of TensorflowJS. And I also doing a kind of in Chhattisgarh, basically a small community called OpenGo community. But apart from that, a lot of talks about me. But I guess let's get into it. Cool. So but just giving a context about what is machine learning actually. So machine learning is the process of taking existing known data and using it to create, or if I will say, create an inference model that can let us make prediction about unseen data. And the process of building the world's leading machine learning framework has been that's the major motto behind how total machine learning works. Cool. Now, going to the main thing around TensorFlow around it, because why should I say, like, because here we will talk about some of the frameworks on a side by side thing and how it leads to thing, and how I will tell about how other you can contribute to other frameworks also, and how I contributed, what is my first PR in TensorFlow org, so that it will helps you a lot better around it. So talking about here, in 2016 when Google first open sourced TensorFlow, the world was different place, obviously what it is today right now. But when it came to artificial intelligence and machine learning, the number of people with skill in it were counted in the thousand actually. Now, today we are counted in millions, and tomorrow in maybe in the tens of trillions, if I will say. And of course, as the number of people with skills to create application that uses AI/ML grow, and then the surface area of our platform, like if I will say of a platform, maybe it can be TensorFlow, it can be maybe PyTorch, Hugging Face. Like there's a lot of frameworks out there right now in machine learning, right? Or maybe Jaxify for the instance. Like the surface area of the platform to enable all the scenario needs to grow to on a side thing, basically, right? Now, while there are many audience, I am basically going to primarily focus on the audience of the like software developers and researcher today, but also students also. Don't be take like a kind of high thing like machine learning is not for maybe for beginners. No, not at all. There's a lot of people who's doing amazing work around it. So the major thing, if I will say, if we right now noting about while noting, there are two main types of researcher. If we talk about researching part around it, those are who are focused in researching and advancing the AI technology themselves, and there are those who are focused on advancing overall new knowledge using AI as an assistive tool. In many ways, like that audience was similar to developers, like the second part that I actually shared with you all, right? Now, the main thing came into play. Research has shown in 2022, or kind of like there was an estimated 24 million software developers in the world, and number is due grow to almost double that by 45 million by 2030. Why? Because the major products even right now is building around machine learning or AI. So, and while many of these software developers will have AI and ML as their full-time job maybe, but most of them won't, obviously. But as many as 25%, kind of 25%, if I will touch around it, over 10 million developers will use AI and ML in their development processes. Their primary identity maybe might be mobile development, web development, doing cloud computing, embedded system developer, or maybe Internet of Things kind of thing, etc., etc. But a core part of their job will be training, deploying, and managing the machine learning models. And it's obviously a massive opportunity for many folks to get into this space, basically. So this is one of the you can say. Just give me a moment. Cool. Obviously, like it's build and value, and that most of us enough yet. But solution like Magic is where a model small enough to fit on a mobile and can perform what you will need it to heavy duty expenses tools and maybe particular skill set to not doing good and long ago. Obviously, like I guess this is the feature I guess you saw in the maybe you can see in Google Photos. I guess like if you have a use around it, and same thing if we are talking about more or less around how they did that. And obviously there's some machine learning models working around it, but how to make it very smooth around it, that's the main process behind it, right? Now if we talk about on a different perspective around it, like how they did that, like what's the major thing, or obviously this is the also one project that actually this is really fun actually. So who use an object detection or I don't know what is object detection. It's majorly detecting of different objects, but it depends on you how you do it. Along with the you can see their 3D printer to spot the printing flaws and quit printing when it happens. So that's also it's also plus point to many solutions in it. Like it is minimizing the errors in your day-to-day life. That's the power of AI as we when we talk about it. Cool. Now, or there's one an innovative use of AI to help spot when people fall in nursing homes without using camera in order to maintain the patient's privacy. So it instant uses radar imaging and is capable not just of seeing when a person may falls, but also be able to see around objects and other people to detect fail so that they maybe help maybe in a called quickly way in a called more of a, that's why there's a the whole thing of the 3 meters 30 meters more on a radaring part basically. Cool. Now the second part is majorly focus on the you can say advanced research I can say, but let's not forget also cutting edge of artificial intelligence like maybe advanced research that gives you a thing like AlphaFold, Lambda, Mum, Imagine, much more. Like I guess if you've been into any like have watched any of the Google I/O event, you pretty much know what I'm sharing with you here. Like there's a lot of thing which is going under the Google Brains team, Google AI team actually to working around it. So this is the major thing that I will say around it, and much more in and out around it. But to achieve all this and more in the years, we have been working on building frameworks like libraries, infrastructures, samples, materials, and more. We have learned that the workflow of going from zero to working solution that uses a model typically falls into some common set of stages that like in general any machine learning engineer can can find out around that basis basically. Cool. So the major thing that we that maybe any machine learning engineer work on it, it basically it all starts with data, and data comes in all shapes and sizes from maybe simple text or CSV file all the way go up to the complex distributed and maybe relational databases. When you're working on a solution that enhanced by AI and ML, you need to understand your data and you need code that helps you ingest and pre-process it. What it actually means basically, if you consider data in a form, think like more or like data is just equal to experiences of a human being. So from that experience you are understanding actually what is happening right now. Cool. That's a major thing that we have to focus more on. If I will say around it, on the past experiences only, you can get to understand about that. So once you have your data, you have it in a shape that's possible to train a model with. Obviously, you of course need an API that helps to create models. This can be from scratch. If I will talk about this, can be from scratch where you define the neural network yourself. If you have those skills as well as the ability to tweak and experiment with your model, right? Or it can be an existing model that can fine tune for your own needs. Or of course, it could be result of neural architecture search against your data needs, blah 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 around it. Cool. So whatever the best method you use, the point is the same. You need a framework that let you figure out the best architecture to learn from your data and easy way to implement that. Again, there's a lot of algorithms out there. You have not much time to basically read each every research paper and implement those research paper, right? That's why TensorFlow, JAX came into play around it. They basically wrap up those functions around for you, so you don't have to read the research paper and implement on your thing, right? And if I will say they have a best implementation around it, if I will say around that. So that's why we have more on that. But the next step, once you have gotten a trained model, is being able to have a place where it will be executed, and you can put it in maybe in the hand of your users, from researcher with a relatively small deployment surface area. So enough to prove and defend your thesis, like to maybe to developers who need to scale to billions, and the ultimate need is the same. There's some question that might we get into it. The first one is, how do I get my model in a place where people can use it, can pass the data it, or get inference back? And when I say inference, those who pretty much know what is inference, it's basically think like in that front like if you send input something and how much time it taking from the model to come back as an output, that's called inference, if I will say in a very layman term, if I will say. Cool. So how can I measure the accuracy and performance of my model in the condition that I hadn't previously considered? So these are some questions that obviously came into play. But most importantly, flexibility is the key. And as a result, the need to deploy to anything from massive scalable cloud to traditional web servers, maybe on your system, to JavaScript in the browser, that is to mobile devices like Android, iOS, to the embedded system, maybe running single board computer like Raspberry Pi, all the way down to the microcontrollers that operate in device as simple as a sensor. So a framework that lets you run your model on any of these runtimes will give you the key to the success, obviously. Why I'm sharing these all stuff, because this is an important part of a work line when you're working for a machine learning as a machine learning engineer. That's really important around it. And obviously that, and the most of the developers, if I will say, once your model is in the, you can say, is in the wild and job has just begun, using the model effectively and building a business around it, like any other software, like any other software engineer kind of thing. So it's a process of constant improvement. Models are data driven. A new data in particular about how your model is used, what works, and you can say, and what doesn't, can be generated frequently. So you need to monitor, maintain your model to continue your cycle at the end of the day. Or maybe it can be CI/CD pipeline part of it also, to make it more automated kind of thing. So continuously improving, create new versions of your model, deploy them, and profit. That's a major thing, that how Google also working around it in that term, basically, if I will say. So beyond the software and the frameworks for data modeling, deployment, and maintenance, there's a lot also opportunity to improve the life cycle throughout the escalated infrastructure that optimize each of these steps. Now, in each and every step, you get a job in machine learning region. Maybe in a starting, if there's a data preparation, go for the data scientist part, or maybe data cleaning, like that's a major thing. Second part is the model training, that is came into totally for the machine learning engine. And last part, that the maybe deployment and the infrastructure part, came into DevOps part, that is right now called MLOps part of also. Cool. So, and tools that keep responsible AI top of the mind. Responsible AI is really important, as I guess in the last, in the recent Google I/O, you heard about from Sundar Pichai, like AI is just like a black box. We don't know what came into play. So on top of it, we have to create a tool around it that keeps responsible AI on top of mind, like any other software system. ML is prone to bugs, but with great powers, obviously comes great responsibility. So tooling that helps you spot, prevent, or maybe if I will say mitigate the bugs in powerful AI systems are essential. And it's nice that given that we are really in the early days of AI revolution, that the thought is going into these now. Cool. Now, so what we are building, like what have we been building basically? What we are working towards is a coherent and consistent set of APIs and platforms for everyone, from if anyone from hobbyistic to developer to researcher. So they have a free open source system where all of these will work together in harmony. Like that's the major concept behind it, and we call that vision tensor projects. It's basically the commitment that maybe as more and more developers come online wanting to use AI and ML, and as a scenario get ever more complex, there will be have a free open source ecosystem that meets your need. That's why the major thing around it goes in that front basically, if I will say. Cool. Now the second part, if I will say, is like let's look more into detail, starting with the data part basically. Data in the first R column, right? And if you're building machine learning model, you're probably spending a lot of time thinking about your data. A machine learning model is only as good as the data that is used to train it. So if you want to make sure you have a best tool too. Now, let's talk more deeply around it. Acquire data from variety of sources, from simple text, CSV file, all the way to global scale relational database that I talked earlier also. Once you have the data, you need to be able to pre-process it. Often the real data that you need isn't simply in the columns, but can be in the function of many data items that needs to be extracted. And then of course you need to use it with APIs that works directly with your training frameworks and line up neatly without you needing to write a lot of extra. So you can see a lot of communities are working on the lot of tools that helps you in this part for cool. Now, tools like TensorFlow dataset, a collection of ready-to-use dataset from Google and the community. You can access them with 1 or 2 lines of code, and they're incredibly useful if you want to maybe quickly a prototype a model. So TensorFlow dataset is one of the best way you can contribute to open source. If you think like you can create a data set around in a very systematic manner, like with proper code of conduct, you can contribute to TensorFlow dataset. So one of the best way you can contribute to TensorFlow. If possible, maybe do maybe create some more data set around it in a more structured way. You can go to the GitHub org of TensorFlow dataset and you can find that out, right? And a simple thing like, for example, perhaps you want to build a model for spotting crop diseases and want to see if you build a predictive model with high accuracy and precision, right? If we say the cassava dataset is ideal for this, and you can retrieve it just few lines of code using TensorFlow dataset. If you will see here, what we are doing here, just importing dataset and just maybe equating with and just basically creating a constructor for that and using that in a form of a for loop. Basically, we can directly extract that data just with few lines of code, right? Now, the major thing that we are right now focusing more around it, it's like how we can make it more better, if I will say, right? So evaluate the performance of simple model before you can spend time gathering and labeling the additional data, if I will say. Cool. That's the main thing. But with dozen of data set, coverage for a lot of scenario. Cool. So some of them might be like sometimes like your own will give you a head start in designing your overall architectures. These dataset can be out of box in Python, not just in ML. But if you are using ML, then we are available for, like, if we talk about in general frameworks like TensorFlow, JAX, or any other ML framework, basically. Cool. So you can do that in that manner actually. Variety of domains you when I'm looking through a data set for inspirations, right? I often turn to Kaggle, right? Kaggle is a great way you can basically start learning machine learning. Right now, what's happening in generally ecosystem, people are not able to understand the basics of machine learning, and they're directly seeing to basically get into machine learning ecosystem, like machine learning to contribute. You can contribute, obviously, open source is for everyone. You can contribute to maybe on in documentation part, but on that part, you have to understand this. So I will say Gaggle hosts one of the largest community of data scientists and machine learning engineers in the world. with over 10 million users, 10,000 public data set, and over, I guess, if I will say, 600,000 notebooks. We learn best when we learn from each other. Obviously, that's what called community at the end of the day. So if you compare here, the TF record format and TF data APIs make it much easier to compete, import the data pre-processing tasks like slicing your data. Basically, it is very easy. Slicing your data is very easy around it, right? And basically splitting it, like this is one of the best function, like you can use tfds dot even underscore splits is one of the great functions you have for the splitting it. For shuffling it, you can do shuffle in this manner. Cool. For sharding the largest data set across a number of input pipes, you can do that in this manner. Sharding the largest and augmenting the data on the fly. And augmentation, just think like creating more data from the single, like if I have a 50 MB of data, how I can you can say increase the number of data so that my training goes well. That's called augmentation basically. Now the training part. So you have gotten your data, you have it pretty good shape. Next up, you want to see how you can use that data to train a model for inference, if I will say. Cool. That's a basic thing around. Now, when you start your ML journey, it can be seem so alien and complex and abstracted, if I will say. But this is what I can say. It's a more maths part, basically, if I will say. So you are used to write to code to solve a problem, but this is a new paradigm. Like, have you trained a model to do it for you? How do you even get started, right? That's the main thing behind it. So, well, let's first look back at the overall ecosystem, if I will say, and the column that makes up the phases of creating ML based product. So we are just looking into the data. So let's dive right into it. Cool. Model architecture definition and training. Now there are a number of options there you can use. You have likely heard of Keras. Recently Keras core have updated with proper, like with your just Keras core backend, you can switch from TensorFlow to PyTorch to Jax. Like these are the three. Just you have to change the backend of part of it with use of Keras core. Right, so let's take a look at these and how you can might use each one of basically. Cool. And model architecture definition, and if I will say, and training. Now there are number of options you can use here. You can maybe, you have likely heard of Keras, right? TensorFlow and Jax. So let's take a look at these and how you might use each one of them. So Keras, I will start with Keras. So it is designed to make bringing AI models to code very easily with an API that works for this from the simplest world, like hello world, right? Models basically. So if you will see, this thing is kind of a hello world for the, like, creating maybe a sequential layer, if I will say, for machine learning. Cool. Now, all the way up to the cutting edge research oriented models like this one, which incredibly can understand what an AI pays attention to when it classifying in images, and which can segment the image into background and people. Like that's all. At the end of the day, we have to work on you can say um, application point of view, right? So there are some great stuff that is happened done in Keras from this pathfinder model. Like you're basically finding a path basically around through that from Google research that can predict the content of previous unseen room in a building from a single observation. That's how cool it is, right? So from a single observation, it can basically see an unseen build around the major thing. So to this wonderful solution from the community, it detects hidden object behind a large object using radar and convolutional neural network. Again, it's a part of one deep learning, part of a deep learning thing basically. Cool. Now, more around it. So, and if you're developing for a mobile or embedded application, I would love to introduce to TF Lite Model Maker basically, which is, as its name suggests, it's designed to take a complex task in a model creation, such as data processing, training, evaluation, model optimization, and conversion basically. Cool. And wrap them in a easy to use API that create a production ready TF Lite model. And your code can be reduced from this to this basically, from, and then these model to this basically. Like there's so much difference behind, right, in this actually. Cool. Now, and importantly, to build an app or a site, you need to integrate your model into something. So here's an example. Is a high level architecture for integrating an ML model into an Android app. If you will see, there's a function called bitmap. Obviously, you pretty much know it's some kind of, obviously, if you use it, what you're doing in an app code for model inference, what I'm creating, creating tensor, putting tensor into the model, and it's sensing out with the metadata integration basically, right? Now, if we will talk more about it in a more general way, the clue is the name TensorFlow, tensors flow in and tensor flows out basically. Simple thing is. But you're probably more used to dealing with bitmap strings and maybe CV pixel buffer than tensors. So we created the task library to help with using the model and multiple platforms, including Android and iOS. If you're an Android developer, you want to get into machine learning, this is the best way you can do it. Just create a basic model of image classification and you can start with it. Now, and we're delightful to basically, if I will say, there's a task library which support in different things. Why I'm sharing you these kind of things, because you are, if you see here, you just go there and to understand what is happening actually. So basically it supports majorly the device large scale similarity search through maybe searcher API powered by Scan, Google's cutting edge similarity search library basically. So obviously I'm not going into that. You can search it out now. The main task why we came here actually, like how to contribute to an ML project, right? That's the main point that we are here, right? How we can do it. So I will share something with you all, okay? And I will just basically compare that thing with what how I contributed. So I contributed to TensorFlow.js, obviously. Cool. So here is a way you basically work on it. Maybe if you will say contributor license. So these are a lot of things. So first of all, you have to understand. First of all, contributor licensing agreement, you have to basically fulfill that. You should go with different thing on the code reviews. Continuous integration is the way you can do it. Contribution, filing a GitHub issues is also a contribution that you can do it. If you're using a product or maybe a open source project and ML project, I also share with you how I, by raising a issue on one ML project, it's kind of a contribution to that. Good place to start, and you can add functionality to that and code reviews. So before getting into each and that part, basically, if I will say, so let me go to one thing with you all to understand a PR that is merged of mine before my G. So actually that will help you understand in a more better way. So let me share this tab. Let me check if it is visible or not. Cool. So this is my first PR that is merged actually. And the key importance behind why I'm sharing my PR, merged PR basically, is to tell you folks how you are using those part basically, and how you will communicate. Communication is key to everything. This is really important. And in open source, patience is really matter here. So here what I did actually, if I tell you in a small gist, basically, I added some kernels, and how I started off, I understand like there's kernels around it. So I just write a mail to in a Google group basically, which is a mailing list of TensorFlow or TensorFlow. Like I am a new folk in this community. I created some projects using TensorFlow.js, and I really wanted to contribute, but there is no beginner friendly issue for me. So I basically pasted that thing, and actually Ping Yu, who is my mentor in GSOC, actually reached out to me like with that, like in a reply in a reply form, and he shared me something more. I will share that. But apart from that, is the process. Then I asked with him like, what's the why it is failing like basically. So he basically shared something more around it. I shared why like this the error I am facing. Then basically he basically tell me actually I'm not going into the correct directory to basically do that same thing, have a conversation. I will share my screenshot with the proper, and it takes time. If you will see, it's not getting, I am not getting a reply. If I will say, if this is 23rd March, right? Suppose this 23rd March. So I'm getting the response out 30th March. So it will take a 1 week, because maximum, if I will see, the big organizations maintainer already working on their some other stuff. So they will take a time on Saturday and Sunday, if I will say, to do this for you, and they actually help you around it. And again, you have to ask, even though it's very silly mistake also, go with the questions, do it publicly. Please do not DM them in a personal level. If it best possible, try to do it publicly, and they will share about the issues regarding it, and they will tell me like, have you updated around this kind. So there's a kind of proper conversation happened, and at the last, if I will say, like you can say, thanks for your contribution. like my like they approve my changes around it, and my one of the first PR actually merged here. So this is the way basically, this is the best way basically you can basically contribute to it. Like, and now if I will tell you why I'm saying, if you go to the projects here, cool, and if I go to the project classic one, basically this is the basically they created this thing for me. This is total thing that is created for me basically. And before GSOC, these are the kernels that I actually contributed basically. These are the major thing that I contributed in that term basically. So this is the best way basically you can contribute to it, and it's the best way you can basically do that stuff. And if I will talk more around it, like at the end of the day, it totally depends on the conversation that you are doing. Cool, basically. And let's, I guess, go back to our other stuff, I guess, other stuff. So basically, best way to contribute is to go with the issue part, if I will say. And if I will talk more about, let me go to this tab also. Let me share you one more thing. So if I will talk you about, so this is a project by one of my mentor in ML basically, Somik basically. So actually I'm using his project basically to understand it, but it's failing again and again. I actually DM'd him like, I don't understand why it's why your I'm using your thing. So he said, I guess it's a proper bug. So what you can do it, create an issue, and I created an issue for that, and it's kind of counted as a collaborative like thing, and he basically we have a conversation around it, right? And it is basically a part of a company called Weight and Biases. Basically I'm using their project around it, and just for that, and I'm started working. So I get also, I created an issue and assigned as a assignee as a contributor. So I'm on a side basis I also contributing this to this basically project. So obviously it helps. At the end of the day, it's more on the conversation that you're doing at the end of the day. Cool. It totally depends on what it. Cool. Okay. Now let's go to the next part. I know it's a very kind of long session if you think more or like that way, but there's a one thing that I have to share with you. Jax is also one of the budding framework that is came into play actually, and why? That's the main thing, right? So Jax obviously to an it's a part of also Google ecosystem obviously, and they have a kind of a better, they have a like a it's basically focused on the high performance computing to advance the ML research. So it's basically a NumPy inspired interface basically, and it get lower level for more power. So it's basically, and it also support an XLA, which is an accelerated linear algebra compiler, which actually helps you, because in generally when you using linear algebra functions, it takes a lot of time to do it, but actually make it very reduced around it. Cool. And also some project like DeepMind Alpha basically, like if we'll say, if you could unravel the protein, like the DNA part, if I'm asking, I'm talking here, right? It's like a string of beads made of sequences of different chemical, obviously known as amino acids. Those who are engineers, they pretty much know about it. And these sequences are assembled according to the genetic instruction of the organism's DNA. And so these are the part of like they are working on the and the, if I will say, the attraction repulsion between 20 different types of amino acids cause the string to fold in a feet of, you can say, so spontaneous origami basically. So for decades scientists have been trying to find the method to reliable determine a protein structure just from their sequence of amino acid, right? But experimental technique happened, but these all things, JAX was the heart at the in terms of numeric computing basically. It takes a lot of time to do it, so that's why JAX came into play around it. And in particular through TPUs and TPU spot. To those who didn't know what is TPU, it's a tensor processing unit basically, and which also, so for example, if you're a TensorFlow developer, you want to take an advantage of this kind of power, obviously, like from that part basically. Cool. For machine learning, you need an MLOps process and infrastructure that is machine learning operation basically, a kind of a ML plus DevOps kind of thing, if I will say. And TFX is a great place to start, like TensorFlow production basically. It's a great way to start. As the world and your business change, you will need only CI/CD, but continuous training too. TFX make that possible. It also helps you understand your model's performance at a deeper level, so your customer have a great experience with your product, obviously. Cool. And it is used by many Google products, like and by the company like Spotify and Twitter with over 10 million downloads. Like you can check it around, it can be more than now. And That's a pretty good. You use an app and submit it, use a TFX, obviously. Cool. And as you work to build responsible machine learning system, model card helps provide the context around it, basically. How it, basically, maybe we are so maybe it's more on a model card generator for the pipeline component. If I will say, if you go around the code, you can check that. Cool. A very popular API and TFX is TensorFlow Serving, which allows you to deploy a model on a server and perform remote inference, basically. So this is the best way you can do it. You can check it out if you want to. This is the best way you can do it in a more. It will be Flutter app, web app, or also native mobile app also, like through Android, if I will say. So this is the way, like so what Google actually is they launched for 4 new learnings pathway for Android, iOS, Flutter web developer to learn how to deploy a model around it. And you can go to this link, basically, goo.gle, and learn ML basically around it. And TensorFlow recommendation plus Flutter basically around that part, basically. Same kind of thing in a more better way. You can go around and yeah. Same thing. And when it comes to deploying on mobile app, you have gotten a great feedback from Android developer who love using TF Lite, but don't like the burden of deploying the runtime with your app. Continue. You can basically updating their app to get the newest version basically around it. Cool. This is the way around it. But I will say thank you, folks. I hope so. You got something. And I know from my end it's very kind of late around it, but yeah, that's my case, I guess. And if there's any question around for me, I will love to catch up. And yeah.
Cool. So I was speaking and my mic was muted, but it's fine, I guess. That was quite a great explanation, Kartiki. And I have a couple of questions in front of my eyes and on my screen right now, and you actually answered a lot of them just by covering this explanation. Uh, Most of them are related to contributing in open source as a beginner. So I'll first take those, and then I'll take a little bit of non-ML questions, maybe not technical questions, and then we can wrap up the session. So the first question is,
Sure.
which you have already answered, but if you could focus on this one, is
Sure.
I know the basics of ML, such as a bit of maths and how to train and fit models. But whenever I go into an ML library repo, I cannot understand anything. How do I start contributing? And this is one of the questions that I have heard from a lot of folks a lot of times, because you know using a library and knowing how it works is very different. So if you could focus on this.
Cool. I guess talking more about that, actually, if I will say, um, think like you have to firstly work on some ML projects. Look, so before contributing to project, you have to use it. The reason why I am saying, because if you do not use that product in your so suppose if I'm taking of my example, how I started contributing TensorFlow.js. I use TensorFlow.js in my small project. So actually, if you go to on my GitHub, there is a project called linear regression model where which actually I use from p5.js. But what I did for linear regression model, actually, I make it more graphical represented using p5.js, and where I'm using TensorFlow.js there also, and it's also deployed on GitHub pages. You can check it out if you want. Otherwise, I will share with the link with the team. You can check out on my GitHub, and you can do that. So the point is, what I'm sharing is, you can't able to understand the repo because you are not using that repo. When I'm saying using the repo, that means I'm using the project. TensorFlow.js is a framework, right? You can firstly try to use in your small projects first. Then you can only understand it. If I will share some, I already share one GitHub issue that actually I'm using one project. Cool. And I'm not able to understand how it works. So like I'm using it and it's keep showing me error. I'm asking why it's happening. So I basically ping the maintainer of that particular repo why it is showing error. So he give me some tips. You can tune in this manner, write in this manner code kind of thing. But after a lot of 4 to 5 times, he said like this is a kind of a bug. I guess you should raise an issue, and I will assign you. If you think you can work on this issue, that will be great part. So this is the way how you can start contributing to it. Firstly, use that project. So again, I'm sharing my screen just in case if you want to understand a more better way. Give me a moment. Okay, I am guessing this is thin, right? So if you will see here, let me check, is it my screen? Yeah, it's visible, cool. So if you will see here, before this part, if you will see, this is the basically import error that I'm getting in my collab actually. And I basically shared this thing with the maintainer actually, basically Somik basically. And I saw basically we have a conversation also going on the WhatsApp also, because I know him personally. Like, this is the problem, bhaiya. I don't know why it is showing error. So basically he give me some idea like, no, maybe you're doing this, but at after a long time it basically stopped that thing basically, and they say like, I guess this is a proper bug. What you can do, raise an issue and give a description why. So if you will see, this is the error actually I'm going through. So actually, I'm porting for basically a model from OneDB, that's OneDB add-on.keras, import this metric logger. So this, they are throwing an error like there's an ops issues. Okay, same thing with happening with here, like it's saving the, and this is the collab link also. Like, I shared each and everything, and that's why like I'm unable to create directly create an issue for you, but I can provide you with a template kind of thing. And I basically shared the what is the title of it. So I am here, it's showing an import error when using NumPy iterator. And when I go to, if I, or also what happened here actually, if I will share with you, this is a part of related to TensorFlow core or TensorFlow core C++. Cool. So when I go to the repository of TensorFlow C++, I found out this part, that this, if I will say NumPy iterator, it is vanished from that code. That's why it's showing error. Now I have to implement that stuff in maybe here for that, right? This is the basic command line. If I will talk about, even though I have a SOMIC around the discussion, like I guess this is the thing. I guess this is the thing we have to share, but same thing. But now I hope so you got my point. What I'm trying to show you is like, firstly, use those products. If you are not using that kind of thing, you can't able to understand that. I hope so I clear your doubt. Yeah.
Definitely, definitely. Now the next question is uh, TensorFlow, PyTorch, JAX. So much to learn. Feels pretty overwhelmed. Where do I even start?
Okay, same question for web developers. You have Angular, you have React, you have Vue.js.
True, true.
So much there. How or from where you can start off, right? So the thing is, you have to first pick one thing. Maybe TensorFlow, JAX, PyTorch. Um, there's a lot of things. I will still prefer JAX around it, but again, there's a lot of things. But I think TensorFlow, like as a Apple ecosystem, they have everything covered in you basically. So maybe if you are starting off, I will still prefer go with TensorFlow and start get small you can say small apps or small web apps for you for more understanding of it. Then you can basically do it. So also again, if I will say, don't go for frameworks also. Let me say that also. Firstly, implement something from core machine learning thing perspective, like create maybe a gradient descent algorithm, which is one of the basic algorithm in if we go for the loss function kind of thing, right from scratch from Python basically, without using there will be no TensorFlow, Keras, or PyTorch, X, so that you can get an understanding of ops concept also. So many people think that there's nothing to go with the foundational concept that is taught in college. Yeah, the thing that is taught in college is not pretty much good, I know that, but what they're teaching you, that's important. Like, many peeps don't know how to create an object, what is the use of classes actually. There you can get an understanding about it, how you're implementing that stuff. So I hope so I cleared your doubt, I guess. Yeah.
Definitely, definitely. And on that note, I have even a follow up question. Uh, it is to even start with TensorFlow, there is a lot of machine learning and a lot of algorithms. Does that mean to start contributing first, I'll have to learn all those and even maths related to all of that? Because because before you go into deep learning, you start with machine learning, and in machine learning
Yeah.
there are a lot of like svm and then linear regression, logistic regression, then there
Yeah.
are trees, ensemble methods. So does one have to cover all of those before going on into deep learning and then contribute into TensorFlow?
Okay, that's not the thing. Suppose I'm giving you an example. Mm, Suppose if you want to play cricket, cool. You have a tendency. What you are saying right now, I'll let me make an analogy around it. You want to play like Virat Kohli, but you didn't understand how to hold a bat. So I am not saying directly go into the algorithms part in a more like one of the biggest algorithm kind of. No. I'm not saying that. Firstly, understand the basics of machine learning. That's really important. Machine learning, deep learning basics courses are available to it. Deeplearning.ai have one of the best thing you can go with. Maybe if you want to understand more betterly, you can go for the Stanford University's lectures. It is totally free on YouTube. Everything is free on YouTube. You just want to go, want to understand, and want to implement. So the analogy is here. What you're trying to think, I wanted to become Virat Kohli. Cool. But the point of here is you can't able to hold a bat. First of all, you have to understand how to hold a bat. So I'm not saying directly go with. You have to firstly understand each and everything mathematics around it. Again, you're a part of college. I guess in college mathematics will be a math one, math two, math three. There is a three subject will be there in your third or fourth semester till third or fourth semester of your college school. Use those knowledge and implement that stuff in maybe machine learning. But understand the basic thing. Maybe if I will say gradient descent, maybe implement gradient descent in C++. If we not possible, try to that implement that stuff in Java. Suppose implement that stuff in Java. If no one is doing, check the what's the rate. Actually, it will give you an answer around it. So best way to do it if there is already implemented something in a very basic algorithm implemented. Gradient descent is very basic. If I will say linear regression also is one of the basic algorithm. Y is equal to mx plus c. That's the concept behind it, right? Yeah. If I will say y is equal to mx plus b, bias and like that's part weight and wx plus b, weight and bias basically, right? So how you basically implement that stuff in Go language maybe why they why you have to listen like go with Python C++ only for machine learning. If I will say try new language and compare both. Like suppose there's already implemented something in Python, right? Implement same stuff with Go language and check like is everyone is saying is correct or not. Is it like everyone is going for Go Python, like Go Mojo, Go maybe C++? Why are you basically restraining yourself just to like other people is saying? That's why you have to follow. Implement that stuff in Go language. Try to do that. You can understand a variety of things around it. So first of all, you have to understand a little bit basics out of it. Differentiation is a common part of it. I guess everyone knows how to differentiate what is local minima, what is local minima, local maxima kind of thing. So these are the some stuff and stats, basically basic statistics. If I will say how to do mean, what is probability distribution, probability distribution graph. If I will say these are the basic things that you already taught in 11 12. If you pass from 12, you pretty much know a simple a little bit about of mathematics around it. So you have to use that thing. You have a knowledge already from 11th and 12th, and you have to just implement that thing into maybe in an application form basically. I hope so you get my point what I'm sharing. So yeah.
Definitely. And making an analogy with cricket, especially in the World Cup season, would have definitely helped everyone. So we'll take a last couple of questions, and well, let's just let me just clear two questions in one. And so the first question is, should I quit web dev and start learning ML, as most of the web dev jobs will be gone in the near future? And this is a very trending part because everyone is saying stuff like this. And the second question is related to this only, and it is, I know most of the jobs in future will be taken by automation and ML. I know that person knows, but still, but I don't enjoy studying ML. What should I do? So, can you like focus a bit more on this? If what to do? What
Actually,
about web developers?
I shared these thing. Actually, I shared this thing in my in my talk also. It is not necessary you have to learn ML. If you're not enjoying like enjoying to do ML basically, don't go with it. There is not a pressure to like obviously go with it, right? But if you know a basic understanding of ML, so that you can implement in web. So I contribute to TensorflowJS, but my the contribution that I did is not directly to machine learning. It's more on mathematics plus software engineering, if I will say. So suppose there is a loss function called sigmoid function, for example, if I'm taking an example, right? So for understanding sigmoid function, you have to understand what is the mathematics behind it, right? Sigmoid function is a mathematic function as at the end of the day. If you maybe heard of in 10th, 11th, 12th, like you pretty much heard about sigmoid basically, right? So at the end of the day, you have to understand what's happening in the maths and just try to implement that stuff. And again, it is not necessary you should understand like totally in depth of ML. If you know the basics of ML, like how a basic neural structure, neural network working around it, how to create neural network, that's also sufficient. That's why in in this total talk, I didn't basically share in-depth knowledge of machine learning. I didn't share about how when we are basically creating neural network, why these number of neurons I have only created to understand that how, like, if I'm creating different layers in neural network, cool. If I'm saying only 12 neurons I have to create, or neurons here, maybe you can say objects, and you are creating objects, cool. Why 12 objects is required? If for that, if you're a machine learning engineer, you have to understand the which function I'm using, and why 12 number is sufficient for that function. Basically, that's came into machine learning. But if you're a web mobile developer, or maybe if I will say DevOps engineer also, like around it, you have to understand the basics of ML, how their model is creating. Apart from the internal mathematics, you didn't have to go to the internal mathematics. You have to just to understand these are the things happening this way. This will give my model training kind of part. So that's why I already stated that model training is the part of uh, machine learning engineer, not a web developer. But when machine learning engineer did this, you have to create an API out of it and use it for your company, or where you are basically using it for that, for that sake, actually, at the end of that. And if you understand more about machine learning, how to get into it, I can maybe say People of AI by Google is one of the podcasts that is there, and you can basically check it out. There are a lot of people basically share their knowledge around ML basically. So my major take is how you're using in that front. I hope so. And the second part is, yeah, automation and ML is obviously there. You are not enjoying studying ML in that sense. So no worries. Oh, say there is a if you search on Google teachable machine learning, you don't have to write a single code for training a model. Just search around it. You can basically find out. This is a part. The teachable machine learning is a concept of transfer learning basically. Without writing any code, you can train your model, just adding some data to it. That is concept of transfer learning. Like, there's already a model is given, you are basically adding your data to tune on your basis. And that's what, say, if I will say around it. I hope so I cleared your doubt. Yeah.
Definitely, definitely. Well, I guess that is it for today because we are done with all the questions. And I would like to thank you, Kartike, for joining us in such a short notice and in such a tight schedule. So thanks a lot for that. For folks who are,
uh,
yeah, go ahead, go ahead.
no. This I'm saying just thanks for inviting me, Adarsh, and the whole We Make Devs team. I love to share my thoughts around it. So thank you so much for inviting me. Yeah.
Definitely. And for folks who are watching this, after the live has ended, you can go ahead and check out Kartike's Twitter and everything. And Kartike has a live stream scheduled in half an hour on with Sayam Patak. So I've just shared the link. You all can go and check that out. I believe it's going to be an amazing stream. Other than that, you can follow me and Kartike on Twitter, LinkedIn, and all the other socials. All the links are in the description. So go ahead and check out Kartike's all socials and do connect with him on LinkedIn. We have our last community calls scheduled in the WeMakeDevs Discord server on Sunday, 8:30 p.m. So do join in and let's end Open Spectrum on a high note. Any last notes, Kartike?
Just I will say, please do not scared of ML. Think more like do in this format on a learning basis or enjoy basis. If you're really passionate about ML, so don't think like there is so much people are doing better than me. If I will say, there's a lot of people who are not doing better than you, obviously. So think in a more positive way. Many people I know, like even me also, I scared many a times like I'm not doing anything around ML. Maybe I have to put more work around it. But yeah, it's always a motivation for you, and community is the best way you can get an opportunity to basically to do that. So keep contributing to community. It will help you a lot in a longer way. Yeah, I can surely say on that thing. So yeah.
Well, that it has been a great session. Thanks a lot, Karthik, for joining in. And I'll see you everyone on Sunday. Tata and bye bye.